Hello guys, Vikas here. Welcome to my channel, and today we are going to make this Iron Man suit build-up effect. It is made in Houdini and rendered in Maya, so we will follow same. So we will build this effect in Houdini and we will try to render it in Maya. We will transfer each geometry separately so that we can assign different shader to different type of materials. So you can see here there are several layers of effects. There is outer layer outer layer of shield and inner layer of thick circuit and some more glowing circuits, some more thin circuits. So we will all build it in Houdini and we will render it in Maya. So let's start it and make it. So let's start to build it up. So pardon my English is really very bad, so please cooperate. Now we will make a geo node. We will name it Iron Man. We will take alembic node and we will import all the geometry. Iron Man, and we will import eye belt. And this is eye belt. Now we will import eye interior. Now we will import shell, the red shell. This is the red shell, and we will import red shell and yellow shell. Yellow shell. Why I have separated yellow and red shell? If you will see, there are two type of shader, and if we are going to export it in Maya, so to avoid shading calculation, shading stuff, I have divided it into two geometry, separate geometry. This whole red thing is a separate geometry, and this whole yellow thing is separate geometry. This interior which is glowing is separate, and this interior belt, the outermost coverage of this eye, is separate. So if you will see, these two have UVs and these two small geometry don't have UVs. So in this Houdini only we will try to make UVs, unwrap UVs of these two. These two are already having UVs. So let's convert it. And let's see if geometry is quite good enough or not. Yeah, it is looking quite good. Put a normal node. Avoid any type of disturbance or any type of, I think normal is not working good, so just ignore it and let's move further. So to for this we can, for converting it into honeycomb, we can take divide. This divide node has a dual computation ability, which can with the help of its geometry shape, it can convert it into honeycomb. But due to just topography of this geometry, these honeycombs are not exactly looking like honeycomb. It is getting a stretch. So for to get rid of it, we will take a remesh node and we will remesh this geometry. So as you will see, it is trying its best to convert the it into equilateral triangle. So as you will decrease this length, you will get more dense triangles. So you can see there are more dense triangles nearby this, but because of normal these are not looking good. So let me off the normal. Yeah, now it is looking good. So ignore this normal and let's see. Now if I will attach this, so you can see there are some fault, but we can ignore this. Yeah, there are ways to fix it, but for now we can ignore this because this honeycomb is going to be visible for this part only, for the transition part only. So we can move further. So let me reduce this remesh. It is quite dense. I think this is good. We can go with this value. So now what we will do, if you will see this our UV got disturbed. The UV is totally messed up. Till here UV is there. Remesh is trying its best to preserve the UV, but divide after divide UV got disturbed. So how to get back UVs? I will take attribute transfer. Attribute transfer, and we will transfer the attribute from convert node, and we will disable this primitive endpoint. We will enable this vertex and we will select UV. So as you can see, it is trying its best to preserve the UV, though some geometry got lost, but we can increase this threshold value and other value to its maximum. Like we can make it 0 and to this 100 not, it will take much more computation time. Sorry, 35 or 50 is enough. Actually it is not impacting that much, so let it be 10 as geometry is near to it, so 10 is quite enough. So now we will take file now, file cache and cache it out, so that this remesh node is quite heavy, so it will take time. So to avoid this thing, I will cache this out into img tutorials argument cache, and this, yeah, yellow shell, cache it out and render it out. Copy this whole network and same thing with this red shell also. As you can see, it is calculating here, and yeah, it is quite fast. So now cache it as red shell, honeycomb shell, cache it. Now load it back. Now we will do same with these two also, as these two also are going to build up. So as they don't have UVs, so we can do automatic because they are not that much visible, or we can ignore it. We can ignore the UVs because as you will see, this is looking like almost this is not visible, so I'm ignoring it. You can do text, you can do UV unwrapping in Maya and import it in. You know how to do it. Now this interior part is almost glowing, so it doesn't require UV. It means it doesn't require texture. You can do it with shaders. So let's export this out to name it red shell, not red shell. It is honeycomb. I guess, I bet. I bet. Cache it out. Copy this whole thing and paste it here. Sorry, by mistake I'm copying this normal nodes. Interior. So you can see now. Okay, so this whole thing we can merge, and we can see whole geometry is converted into honeycomb mesh. Yeah, there are some gaps. That is just because of geometry. Those who are not stitched or they are separate apart. Though we can ignore it. So let's start with building this interior circuits. In this part we are going to create this this circuit type structure which is inside this cell. So for this I will combine this two, and I will pick it down. So I will take sorry merge, and I will combine this to geometry, and I will pick it down. So for picking it down I can use pick, but in this case PK will not work as I'm expecting. It is not working like that. I want this should be inside this, so that like what I want to say, let me explain it. So let me take new notes. So if this is the original surface, I want to pick it down to this level so I can generate this circuit wire over it. So there will be no out penetration. To do this, what we can do, I can generate point normals like this, and I can move each point along this normal. So as peak is not working as I expected, so I have to do some this type of stuff. So let's start. So delete this. I will take point old, and then I will create normals which are pointing out from the center. So I will take add normal, delete. I will take $cex minus $tx, $cey minus $dy, and so on. $cez minus $tz. So as you can see, though they are inside, but it can work. It will work. To make it outside, either you can do $tx minus $cex like this. $tx minus $cex, same. $ty minus $cey, and $tz minus $cez. So now you can see all normals are facing outside. So how to move this? We will take a wrangle and we will update its position. So at the rate p equal to at the rate p, I can do multiply multiply into ch, multiply into normal, direct normal at the rate normal. So you can see they all are sorry, not multiply. I will add it to normal. So they are moving outside. This is original geometry, and they have moved outside. So for this I will ramp this normal. I will take ch, and I will take int like multiplier, and I will multiply it with normal, and I will make whole expression in bracket. So you will get this type of slider. So for minus, for making it inside, let me off this visualizer. Let me template this, visualize this, and if I will make this value all go down to lower than 0, and you can see it is going, this geometry is shrinking it inside. As peak could also do same thing if I have yeah. peak is also doing same thing. After making normal in some direction. So this is how, I think this is how peak is working. It is moving all geometry. So let's take our own setup and we will make it shrink inside, and we will generate some wire work. Now what we will do, we are going to read every pieces of this geometry separately. There are several pieces in this geometry. If you double click, you will see this geometry is not of single. This geometry is not made with single mesh. It is in pieces. So for reading these pieces separately, I will take for each loop with connectivity. Now you can see as their class is being generated, and if we will all will go down. You can see it is point. You can name it to primitive and name it C and it is class. How it will work? Oh, sorry. Oops. So you can see this is being generated to make it on primitive. Now you can see we can read each part of this Iron Man shield. We are able to read. So now we will make we will short it out. We will short point number so that we can get uh, a number from upside 0 downside 1. So we will use short node, SORT short, and we will try to short it by y. So it is shorted. We will take group and we will name this as start, START start, and name it as 1 0. We will take point 0. So we will see whether 0 group is 0 point is grouped or not. As you can see, 0 is here and it is grouped. Now we will take group one more group node and we will name it as end, and we will try to take points, disable this, include unshare ads. So this will select all this outer layer. Now what we can do, we can take path, find shortest path. Here what we can do, we can select this. Start point will be start and end point will be end. We will make off this. Now you can see all point are generating from 0, and it is according to this surface, this whole thing is being generated. If we will off this, you will able to see some circuit like structure all over mm, this element shield. Now what we can do, we can copy this whole network and randomize the value. Copy paste, and let's do short again and use hash short and randomize the point number so that we can get another, like randomize it with other seeds and you will get other iteration. Like this is looking quite good. Now what we can do, we can merge it up, merge this all thing together, and you will get some thing like this. So this we can use as uh, uh, let's see how we can go. So so we can now we can use polywire to convert this whole thing into uh, this type of geometry. Now if you will see, there are too much messed up. So for this, what we can do, if you will see, there are very less point numbers, so we will use resample. to resample these curves so that we can get like 0.02. It is quite good. Now if we will use polywire, we can see there are something has improved 0.01. Let's decrease the radius, and now mhm, now we can see this has given us quite good look. So as you can see, there are some small thin circuits, and there are really thin, very thin circuits which are glowing. So what we can do, first of all, let's delete some of the primitives. So we will group by expression to group it randomly, group by 30% chance primitive, and delete it. Now what I can do, I can select group 1 and delete it. I can take like 80%, not 80%, 80% is quite. No. Now what we can do, we can use a swipe node, swipe node to generate thick thicks. Like I can take I think I can take circuit and I will convert it into polygon open arc, and I will try to make it in this way, use transform so that I can rotate it, and now I will attach this to this, and as you can see, mm, you can use skin close skin to make it like before doing this, let's decrease this size. Before doing this, let's decrease its size 0.1, sorry, 0.1. And now I will resample it so that calculation can be not too much. It will take time. Now you can see this is building quite good looking um, stuff. 0.025. Now you can see this whole swipe node is creating something like meshed, like it is, as it is not along to this axis, so we will rotate it like this, like 45 degree. And now we can take another transform, and what we can do, we can scale it like this, like squeeze from this side so that we can get that like this type of effects. Yeah, it is quite good. I think it is quite thin. What we can do now, we can delete some more points, like not 5, like 7, 5, 7, 6, this type of, so that this element should be reduced more. mm, let's take more, 8, 5, 8, 6. I think it will work, or I can plus the value for randomization. I can get some other stuff here. It is quite good. What we can do now, it is making it like circular path. So what we can do, we can reduce 0.07. Now as we have reduced the, its calculation will be quite fast. Now let's template the original geometry and see how much we have shrinked. So as you can see, this whole thing is like quite good. Yeah, we can increase this width. We can increase the width of this like 1 from 1 to 1.75. Yeah, it is looking quite good. Now this poly wire is looking like is at same distance. So what we can do, we can make it more thin. So before making it more thin, if you will see some glowing wires are on they are on this thick circuit. They are stick to thick circuit. How to achieve this? What we will do, we will take this thing, this wire and this surface, and we will try to take ray shop, and we will attach this wire to this. So now if we will see ray, as you can see, let me bring out this template points. This ray thing is making this whole if you can see this whole thing getting stick to this ray. So let's take to minimum distance, switches to minimum distance, it up. Now this thing, and use poly wire after this. You will able to see now you can see this key looking thing. Now I can reduce this division level to 3, so that mesh will be uh, and I can reduce the width 0.025, so that it can look like really thin wire. Yeah, like this. Now you can see ki, I'm plugging it into this merge, and yeah, it is looking quite good. See, let's color it. I will give it a bright blue color. Now you can see, let me now you can see this whole uh, thing is looking like circuit types connected to each other. What we can do, we can take another this surface, and we can make more dense. So I can give this value to like 3. It will be invisible on this paper. So now let's lift this value 0.2, and let's see if this wire are getting out of the surface or not. Yeah, it's quite messed up. I think 0.2 is too heavy to apply. Let's take 0.01. Yeah, 0.01 is giving quite good result. Okay, let's do what we can do. We can create VDB out of this, because this type of thing will look too much not look good. So for this we can use fill, polyfill, and if you will see, this whole thing has been filled. Like we can use a single polygon to fill the edge. and now we can create VDV from polygon. At this scale it is looking too weird. Let's reduce the voxel size and see whether it is working or not. Yeah, it is working. 0.15, 0.015 actually. Now convert it into polygon and see whether it is looking good or not. Yeah, it is looking like, yeah, it is looking quite good. You can, what we can do, we can reduce furthermore to 0.008 to get some really cool details. Yeah, this is working quite good. Now instead of this ray we can use this geometry to wave project this, because there are too much polygons and it will project really very good. See, now if you will see, yeah, see, this is working quite good. Now we can merge it this and we can see whether it is working or not. Yeah, we can see some of the edges are looking brighter. Yeah, it is working. Now what we can do, we can take this whole thing, or we can copy this whole stuff and copy and paste it again. Now as we have, sorry, make it, set it here, you can see we have made this. Let's save the file. Let's save it as horizontal. Now if you can see this circuit, it should be above this all whole stuff. So what we can do, we can reduce this threshold value. So for this what we can do, we can increase this value to, like, make it 0, so it will be on surface, or we can reduce furthermore to like this. We can use this 0.3, and this we can reduce more to 0.9, 0.0.2. Let's see how much in cat. Yeah, now we can see, okay, it has reduced much inside. So now to make it more visible, we can make it go more inside, like 3, 0.03, 0.04 or 5 will be enough. Yeah, now what we can do, we can randomize the value. Sorry, we can do take short SORT short and randomize the point number. Yeah, let's do more randomization and see whether we are getting. Yeah, I think this is quite good. This result is quite good. And let's make changes in this too. Yeah, and I think this is looking good. Now we will take polymer, resample it before applying polymer on it. Let's make it a 0.0. Yeah, 0.02 is quite good. Now this will reduce the radius 0.01 or more, like Yeah, 0.041 is no, not good. 0.085, 0.0085. I think it will look quite good. Let's reduce this further more. Yeah, yep, this is looking nice. So now let's attach. Let's do what key. This whole thing we can do like attaching. For this thing, I will create animated geometry so that I can trim it out. Hello guys, in this part we are going to create an animated geometry so that we can create this growing effect, or this growing effect can be created by some expression, color growing, or infection, that infection expressions and other thing. But in this tutorial we are going to animate two geometries, two sphere, and we will create. Let's see how we will do this. Now I will take a sphere, and what I will do, I will take transform. I will make it to down 0 and set a key, and I will take like at the frame 120 or like 100. So at 100 I will make it grow like 1, set key, and we will see it is growing like this. Now I will make it linear. Make this a polygon. Now segments, as this is our this whole thing is our so I will take a transform. I will transform it to this side. So like I will take a wireframe. I will just align it near near that circular ear. Like this. Yeah. Now I can increase this size like this much so that it cover whole thing. Now I will copy same transform node and I will make it to move like this side. I will merge this both spheres and I will see if it is covering whole geometry or not. I can take boolean to see whether it is working or not. Take a null. Yeah, it is covering upper part, but lower part it is not covering the lower part. So what we can do, we can take this and we can increase size in this side. Take this key all the way this to this to this. Okay. To this, no, not like this, like this. Yeah. Now it is covering all geometry. I think that person is. Yeah. Now we can see all geometry is inside this part. Yeah, it is covering up. To see the animation, we can like see this, play it and see if it is okay for your growing effect or not. Yeah, it is quite good. Now what we can do, we can we have to increase more subdivision like 20 or 30 so that 40 will be also quite good. Yeah, now let's cache it out. So after caching it out, we will now do this transition part. We will see how we can use that animated geometry to do this. So for this, what we can do, we can take out this whole geometry and we will colored it as let's color it as black at the value 0. And before doing this, let's write an attribute so that after doing all stuff we can extract it out. So we will take an attribute like id. So I at the rate id, let's say GOID equal to 1. Copy this, paste it, and make it as 2. Same here, copy paste, make it as 3. Copy paste, make it as 4. Okay, before going further, let's check if UV is preserved or not. I think UV will be there. Yeah, it is there. So let's move further. Now what I will do, I will take this and I will color this as 1, and after that I will yeah, I can do attribute transfer on this with this, and we will do this. So I will not transfer everything except color, and I will lower this value and I will increase this value. Template this and let it be like this. Now for this, what we have to do now, okay, we have to make it as not as around this, but I want to with the help of solver, I want this to be as a wet map, like it should not decay, like inside it is getting decay. So I will, what I will use, I will do a whole thing in solver. So let's take solver and second input inside this, and we will take attribute transfer. This is our second input, and lower this value, I will give it as 2 and 0.5, I guess, or 0.3. Yeah, 0.35 is okay. I can increase this so that okay. Now if I will see, if I will play, I will see there is no decay inside this. Yeah, it is working. Let's see if it is covering whole surface or not. Yeah, it is covering whole surface. Now we will cache it out. Let's take file mode and cache this geometry till 155 times. Projecting tutorials, and I will, let's see, get caching. One color, gas it out. Let's see, that is, this caching has been done. So now what we can do for this, what we can do now, like suppose this is our growing part. So this let's first okay, ignore it. Let's first do this part. So for this, what I will do, I will take assemble node and I will pack this geometry because these all are not connected. I think something is missing here. Let me check. Okay. Let's take visit and disconnect whole geometry. Now if I will pack, so I will get this as a single piece. Now what I can do now, we can transfer this color over points, and we can use delete node to delete all the points or geometry which have color like lower than 0.1. I will delete all those geometry which have lower points 0.1 or 0.01. Furthermore, 0.001, or we can write which is equal to 0. So what we will get those all value, like if I will write 0. Let's check 0.000. No, it's not working. So let's see whether, as we are getting this now. Let's check our normal, as normal is also missing here. So let's transfer normal to let's see normal here, as we are not able to visualize normals. Almost with the okay, normals are on vertex. Okay, now what before deleting it, let's solve it. It's normal. If it is not there, I take point, hold, and use same expression, or we can copy that node. We'll take this node. Let's paste it here. Delete this. Now we can see these are the normals along which we want to displace this geometry. Okay. Now we can take another file cache node, and we can cache it out, as it is deleting in this much process have been calculated. So we can save this. Cache. One color deleted means deleted. Sorry, I'm not organizing my work because I'm in too hurry. So this has been cached out. Let's load it and see whether it is working or not. Yeah. So now what we can do, as we have normals, and so now let's start with point walk. Let's take walk, and what we can do, we can take out the length of the color CD, that is CD, and let's add this original position with normal and multiply this with the color. Let's see whether it is working or not. If you can see, sorry, we have to plug it into, see, this all has been moved along with normal directions. So if I will take multiply and multiply this and promote this attribute and multiply with this, you can see it is moving along its normal direction. Now see, so this whole thing we can multiply this with the length of this. As you can see, like if I will increase the value, the red part will go up. So we have to do totally reverse of this. So what we can do, we can import ramp. So let's see whether what the range of the color is. So um, let's plug this to direct inside the color. Let's see whether the color, what are the attributes of the color. Maximum value, I hope so that will be 1. Yeah, 1, we can take it as 1. Hmm. So now we will what we can do, we can import a ram. We can plug a ram, scalar ram or a float ram, and plug it here. Now disconnect this, disable this. Now if you will see, if I will up this, you can see this whole part is, this black part is going up, and this, now you can see like what is happening. No? So what we can do now, we can like take it as, make it as cams, change the version, curve type, and make this like, make it like this. Even though what we can do, we can take another ramp and plug this whole color stuff and name it as SVLG scale. I think polyscale, polyscale. Copy and paste it here and export this with bind export and name it as SCL scale. We can what we can do, this whole thing is red now. We will see, we will get this type of thing. Okay, this distorted type of thing. Now we can take primitive and we can use that scale attribute to scale this like thing. Okay, add that as scale. Scale, copy all thing and paste it here. Now you will see this this upper part is bit scaled down just because of ramp. So what we can do now, we can turn this into Bezier curve or spline curve, B spline, and make it like this. See, even though what we can do, like we can shrink it like this. We can decrease the value amount of scaling, this thing, or even 0.05. I guess so. Yeah, it is looking nice. For this type of stuff, what next we can also delete this part, inside part, so that it could be somewhat like there is no use of this thing, and we want, except in place of this we want our original geometry. Original geometry means this, like there is, sorry, I have not merged the original geometry. Let's take a merge and let's take this, 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 and this geometry. We want this geometry to be visible here. So for this we can let's see, I think yeah, what we can do, we can put some noise over this sphere, mounting over this sphere, so that we can get not, no, we should, we get us some jacketed edge, like not so smooth. So So for this we can use this geometry in delay form. Let's take time, shift, and group it. Let's see, and what we can do, merge. Let's see whether it is working or not. Yeah, it is quite working. Like, see, on surface, and this is surface. So we can now delay this part, like this part, or bit more, delay it by 1 frame or 2 frame or 3 frames. And after deleting it, let's enable this, and by with the help of this, let's group this whole thing and delete all which is inside this group. There are several processes you can achieve this. I'm just giving idea how to do this. Now see, it has been deleted, and if I will merge this whole thing, I will get this. But what I can also do, like copy paste it here, and take a boolean, like it is 3, then take it as a 2, and take boolean, carve this out from this, and to subtract, and you can see A from B or A from B. We can invert this. Okay, this connection was okay. Next I need to do solid surface. So let's take boolean this first input and your animated geometry in the second input, and the second part it is not coming. It is because we are using, like, it is not coming just because we are using these two geometry are separated, and it is not able to regulate. But when they will get merged, you will see this whole thing is coming proper, as this geometry is getting near. I think let's see whether it should work. I think maybe there was some bug. Now what we can do, we can merge this whole stuff and this whole stuff, and we can see it together. If you are able to see this whole building thing. So for this, what we can do, we can delay it like 1, decrease it more, so you will get this stuff. There will be no gapping and all. You can check other frames. Okay. And another thing, what we can do now, we can ramp this, like we can, like we know, okay, we know that we are tackling with the scale, so we can reduce the scale at the end so that it get merged little more. See, I think it is taking a lot of process. Let me make it I will visualize this and edit this. or we can disconnect this and let's take a curve type. Let's change the curve type, let it be linear, and make this like whole thing like this. Yep. And now we can use this. Let's see if it is working or not. It is not working because we need to spread it more. So from here, what we can do, we can actually we can increase this value 0.5 or furthermore like 0.8, so we can get gradual increase in the ramp. Okay, now like we have to cache it. So let me cache this node and another node, then I can resume this. Or what you can do to reduce the calculation time, we can ignore this solver and we can use this attribute transfer. Let's make this value like 1 and we can cache it out. I know it will be a bit faster. Let me pause this video till it's cache out. So just we are ignoring this solver thing and we are using this, and let's see converting point normal and deleting all the unused like this type of geometry. Yeah, it is working. Or what we can reduce more, like we can use like 0.7 or 0.5 is quite enough. Caching it out, caching it again, and I will pause the video till it cache. Let's see, now it has been cached out, and we can after deleting it, I'm putting it in another cache, and I will pause this video. Now second part is also cached out, so let's see whether it is working or not. Yeah, it is working quite good. Now we can see we can see that what I have done. So with the help of this last these also are getting these are also getting up, and if you want to see, we can see this whole thing. This is all because I have COVID down. Let's remove this, and now we can see this. So if I will group this out, and I think I should decrease this. Yeah. But now delete this, and if we will merge this or this, yeah, it is working quite good. This is all what I want. So now as we are seeing, these geometries are like they are going up and then going down, so we can increase the intensity so that it is more visible. See this. Okay, what we can do, we can import more noise over here, like we can multiply some turbulent noise so that there will be an even odd like random movement in this geometry. So we can generate a turbulent noise, I guess. Yeah, we can generate turbulent noise with this, and we can multiply it, this ramp up thing. We can hook it up here, or we can do another multiply, and multiply this with this. As you can see, it need to increase the value. Let's see. Okay, even we can repeat this process all over so that we get some more variation and some more layers. So for that, what I will do, first we will reduce this scaling thing and we will delete, and after deleting that we will do this. So let's connect this to this, and sorry, actually we need this attribute, this scale attribute. So I will disconnect this. I will make a copy. I will rename it as primitive scale, and name it as position noise. Position noise. So now let's delete all these steps. We are only exporting. We are only exporting scale. So I will look at here, and this, yeah, scale is working. Now group and delete. Now we can cache the whole thing again. Oh, sorry, after delete. Okay. Anycom deleted scaled mass. Sorry for name convention. I am just using these names so that I can recognize this. Oh, sorry. So we are facing, whenever we are caching out, we are facing some error. That error is due to this time shift. Actually, we have shifted to frame, and at the frame 2 and 1 and 2, there is no mesh. So actually, we have to do. We can use time time shift again, and actually we can use this. Not 3, 2. At 3, we can delete this channel, and we can use switch between this and this. Now we can plug it like till 3 this will be there. We can read first input, and before 3 we can read sorry, first input, and now we are ready to go. So let's cache it out. So guys, as you can see on frame 1, there is on frame 2 there is sudden pop-up in this effect. So for to deal with this, what we can do, we can animate this attribute transfer. As you can see at frame 2, it is coming like it is like popping it up all of a sudden. For this, what we can do, we can reduce this, like go to frame like almost 6 and key this attribute transfer, and at frame 2 shrink it down to like 0. Now if you will see, there will be growing effect. To match this animation, you can use this. Yeah, this is working. Now I will go through whole caching thing, and then I will resume. I will cache this all stuff till here, and then I will resume this video. Now this caching part has been finished. So I will attach this. Sorry, as you can see, it is quite fast, and as geometry has been reused. So after this caching, I will use this position disturbing thing. So I will connect this to position, and now I will delete this, because as now we don't require all this. Now as you can see that there, I think Normal is there. Yeah, normal is there, but it has been scaled too much. So due to this, the whole geometry is getting screwed up. See, this much. So we can normalize the normal. Um, we can sort it out where this whole thing has screwed up. I think after primitive, so for this, till here it is okay. Primitive, yeah. I think we need to cache it again. So I will cache this whole thing and I will resume this video. Now caching has been completed. So now we will see this is working properly. Now we can repeat this process again and we can offset the noise. Let me promote the attribute of noise, and we can increase the frequency, I guess. Yeah. And we can merge it. We can reduce the strength to again we can, and we can offset the values, and this also we can reduce the noise strength 4 to 3. Yes, it is looking quite nice. I think there is a lot of mesh here, so I can increase more, and I can reduce the frequency and offset it. Yep, it's working. So for this, what we can do, we can leave this thing as it is, and we can delete some more polygon from this. Like we can use delete mode, and we can delete it with the help of expression like greater than 0.4 and 0.8, I guess 0.9. Yeah, we can use 9 is quite good. We will able to see this type of effect over here. Even we can increase frequency a little bit more, 8 by 8 by 8. Yep, it is looking quite nice. Even though we can merge this whole stuff like this, and we can use extrude to make it little bit thicker. It is quite heavy. like 0.01. Okay, so for this you have to convert it. Let's see if the geo ID is preserved. Yeah, geo ID is preserved, because further we have to extract that yellow part and other part. Now as you can see, I have extruded it, and it is looking, this extrusion is quite so I can reduce that, and see whether it is extruding inside or outside. It should be not outside the surface, otherwise you will see some type of glitches. So I will now on it. Yeah, it is outside. So for this I will use minus sign to make it inside extrusion, and I will on background back output back, so that we get applause and cool looking thing. Now it is thick, and it has some feel of. I will do same for this also, because as it is a main layer. Yeah. Now before moving further and doing this, I will extract some more like, let me merge it up and let me show you something. I will extract I think density is low here. If you can see, it has quite more density. So you can use, so we can copy and paste another. And now I can offset it by 50. And some more frequency, we can increase the frequency like 8 by 8 by 8. uh, Before doing this, we can extract some from this, some points, so that we can make it glow like this edge part is having some glowing particle like effect. If you will see, some are glowing. So for that you can extract some point from here. So for this you can use delete. Yeah, we can use delete and delete the point, or we can use delete by expression. Sorry, group, we can use group, sorry, group by this expression, let it be point, and with 30% chance. At that 30% chance we can use this 30%, we extract it out from here. So what you can do, you can increase more like mesh, and make it more amplitude with more amplitude like 3. Yep, it is working. Now we can, after this we can use delete mode, or we can use a split here. We will delete group 1 and points. So we will get this. We can reduce even further like 0.2. So we will get this, and we will extract this and use it as a glowing part. And for this geometry we will use this part. So merge it up this whole thing, and you can cache it out. This whole thing has been finished. So this will be now you can check whether our ID is working or not, like yellow part and that that red part, yellow part, eye belt and other thing. Because as you saw, we have merged everything over here. Sorry, over here. So we have an attribute called ID GeoID. As you can see here, we have attribute GeoID which we can use to extract our data. So before caching it, we can cache this whole step, because at the end it is going to be a glowing part. So we can cache it up. Use file node to cache this whole thing. Get render geo. For this I am going to use alembic flow. So I will use attribute delete to delete all the attributes, because we are going to deal, even we will delete UV also, because we are going to assign a shader over it. So we will use alembic drop output 150 frames cache render GOM and name it flow geo dot abc. Save this file and render it. I will resume the video after it get cached out. So this part has been cached out. Now I will cache this, but before caching this, I will extract the yellow part, that red shell part and eye belt. So for that I will use delete node, and I will use the same name, same attribute name. That name is like GeoID. So I will use @geo_id equal to 1, and as it is on point, so I will, now you can see this whole yellow part, I think this is a red part, has been extracted, or I will name it red shell. Same way I will copy paste it here. I will extract the second part, that is yellow part, yellow shell, shell. Now same I will do with this. I don't know where the belt is. Let me move that frame where we can see belt. It is quite time taking, but after caching it will be okay. So I can let's see whether, sorry, this is what I used to do every time. We have to do it as non-selected so that we can get what we are deleting. So this is yellow part, one is yellow. I think this will be red. Yeah. And to the cell, to the belt, I am deleting the belt, so it will be a belt. Yeah, it is belt. And this will be your ATI part. So I will export each of them separately with UVs. I will take alembic, I will take attribute delete and delete all other attribute except UVs and normal. So here I don't need anything from this, so I will delete everything from point, everything from primitive, and newbies. And now you can see as all part has been cast out. So here all it is quite messed up. Okay. So for now we will move to our wire framework. So how we will make it, how will make this to grow? No doubt we can use other step also, but here for convenience I will use the that boolean thing only. So here also I will cache this thing separately and this wire thing separately. So let's do. I will take this and I will call that animated geometry. This I think I will call this geometry, and I will take a null. I will connect it here. So for this we can use boolean. Mm, mm. Now as we can see it is taking too much time to calculate. For now we will copy that this whole thing, copy it, and we will paste it here. As we are not going to change the animation, so I can copy that thing. If you are changing animation, then please don't do copy, because after doing this type of stuff you will not able to remember in future. You will not remember where you have done this animation stuff. So to avoid any type of error or any type of mistake, please do not copy anything which has been animated. So I think my machine got stuck, so let me check it once. Yeah, so for this I will reduce the I will reduce the resolution of this mesh. So I will like to this thing. This is quite enough, and I will animated geo like version 2. Sorry, I have renamed it as version 1. I will rename it as version 2 and cache it out. It will be quite fast. Yeah, see, this has been cached out. Now I will use this same geometry. As you can see, I think now the calculation will be a bit faster than earlier one. It is taking almost 10 seconds. I'm pausing the video, and after this, I think it will not take time. Let's see. Oh, I think it is going to crash or what? Hmm. Hmm. Where it is. I think I should. So for this, what I have done, okay, let's see. I have converted into VDB, and now I'm just converting this whole stuff into this. If you can see there are uh, some some polygons are scattering here and there. That is because our this geometry is not closed, so we will use polyfill to fill this geometry. And now if you will see, then there will be proper mesh over here. Sorry, I have to use single poly. Now if you will see, this whole mesh will be completed. Yeah, it's working. So I'm removing this fuse, and I'm converting the whole geometry into as it is. Now as you can see, we are all done. Now what we can do, we can use boolean over here, and we can carve out our mesh. It is quite easier for Houdini here to calculate boolean after here, because it was not that much heavy as compared to I was doing here, because there was too much intersection between the between the meshes. If you can see here, there are too much intersection, and boolean is taking time to solve this all. So for this we can use this. For now we can use this, and even I can reduce the resolution of our VDB, so that it will be more easier for boolean to calculate this binding stuff. So as you can see, we are ready. But first of all, we need to see whether our effects like this should be like you can see this stuff is building before outer cell. So for this we will use same geometry, but we will offset the time, like we will offset the time. For that we will template this, and we will use time shift here, time shift over here, and we will do plus 5, I guess. Let's see if plus 5 is working or not. Plus 5 is too delay. Plus 8, plus 8 or plus like 12, yeah, or 11. Let's see 12. Yeah, I think 12 is quite working, though we can increase a bit more. Yeah, it is quite I think it is. Let's increase a bit more. Yeah, it is working nice. Now after doing boolean, we can use we can use VDB again, so that we can get more this type of stuff, and we can convert it. And now this is all ready. Now we can use this geometry for this thing also. So before doing polywire, we can delete this. Let's see if boolean is working over this wire or not. I have never tried it, but we can see this. If it is working, it will be nice. I think I can do surface or subtract or something like this. No, it is not working. Let's see if it is working with polywire. Yeah, it will work with polywire, but it will take too much time. See, it is taking almost and it should be down the term intersection, and let's see if it is working or not. Otherwise there are alternate solution also for now, but boolean will give you a nice look, so that's why I'm trying to use boolean. See, Courtney has crashed. So now let's start taking an alternate solution for this. So as you can see, this is what we are making, and this is our mesh. Yep. Now this is our mesh over which we want to place this. We will connect this and we will see whether it is working or not. Yeah, it is working. Yes, it is working. So for now, what we can do, we can surely we can before after ray we can resample it like this, and we can 0.01 or like 0.001 like this, and we can use group node to delete all this point. Like we can group it here, group it by this geometry, and we can say group the primitive, I guess from points, only points. I think I have given the resolution too much. 01 is quite enough, I guess. Yeah, 01 is quite enough. Now we can delete the whole point, not 10 primitive, or we can we can reverse the deletion process. But you can, as you can see, there are some primitives which are getting connected here, because as you can see these all are a single primitive, so this will no doubt this will create a problem. So what we can do, we can, after converting to polywire, we can delete it by this group thing. For now, for I think this polywire will take time, so I'm reducing this by 3, 0.03. Yep. Now if we will see, if I will if I will I think it is taking time. To avoid this, what we can do, we can bake a single frame over here. Now we can take file cache, bake it here for a single frame, let it calculate. We are going to save this a single frame. So now we will cache it for single frame. I thick wire alibi dot sc. Now I will save it for a single frame. We will do same. I think this is some template, that's why it is taking time. I'll copy this thing too and paste it here. We can thin wire. We can cache it out. I'm caching it on each step so that let's see if it is working or not. This mess has been get too much. I think this whole thing is getting too much messed up, I guess. Let's see. If I will click on boolean, I think there was some loading problem. surface. Yeah, it's quite. Let's see if it is like this only or not. Yeah, yep. Now you can use file caching. So now we can, okay, as boolean is going like there is no cap, so VDB is not able to calculate. So we will use fill again and see whether fill is working or not. Yeah, it is working quite good. Now we will convert it into VDB again, and this will be converted like this, and now we can see whether it is working or not. Yeah, it is working, and here you can see these lines are much more visible. Though it is taking time, still it is quite fast, and it is looking quite good. Both thing is taking almost 11 seconds to get cached. So I will cache it out. Let me save this, and I will use file cache. I think Alembic cache. Sorry, I will use Alembic cache for this stuff, and I will cache the whole frame range. Now caching has been completed. So we will cache. Now we are going to cache this out. This our somewhat thick mesh, or little bit thick, not that much thick, but it is little bit thick mesh. So we will do same step for this. It is quite resampled. There are quite points, so we can use this step. Copy this, and we can use it here. And now we can map it out. Paste and met with wire. Now cache it. We will resume uh, after caching it. I think I should use time shift here. It is calculating every time. So let me use time shift. I think I should cache these two. Load it. Now cache this out. I think now it will not take time. Yep, it is quite fast. So we will continue after caching it completed. So caching has been completed. So let's move to Maya and start rendering.
Hello guys, in this part of tutorial I will show you how I rendered it with the help of Arnold. So for that I have very quickly I have imported all the cast out alembic geometry, and now there is a basic lighting, like I have used like sky dome light, and I have inserted a SDR map. So now as we have exported with group, and I have already made the texture of this Arnold shield. So for this I will assign a material. Let's go to frame like 45, and very quickly we will assign all the standard material, and we will attach our textures. So like I'm going to assign a standard shader, and for this I will hide all other geometry so that computation will be faster. And by side I will on the IPR render. As you can see, this is basic render. So for this I will apply I will apply texture.
I have pre-made some textures, like there is some, like I have made this with the help of a substance painter. So you can use whatever you want. So for this we need to check this specular map and all. mm, uh, so I will attach a roughness map. This is the roughness map, and I hope we will get some roughness. For this, for the roughness we have to use the raw color space, and we have to on this alpha as a luma, and we will get whatever roughness we have. Like map will exactly work according to the color informations. And now for metallic I will assign a metallic map, and that's all. You can do your stuff of texturing. For this it is really quite not that much, so I will use basic shading. Metallic I will also like change the color space to raw, and yep, it is quite. And you can obviously you can tweak with this IOR and all. For this I'm using like presets. You can use the presets for this also, and there is nothing, no preset, no related to. And you know, we can take the correct IOR from net. And now, and same we will assign same we will do same thing with this also. We will assign a new shader, and very quickly we will attach our textures. And for this we will do repeat this process for other part also. So guys, this is the output, and this was my first YouTube tutorial. So I tried my level best to cover each and every topic to make it easier for you to understand this, though it was not that much easy, but I have tried my level best. Please let me know your reviews and your comments so that I can improve for the further videos. Thank you guys.